Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and joining me today is Andrew Hall. Hey, Andrew.
Hey, Robert.
Welcome back.
Thank you.
Andrew is here today to talk about C++ debugging. We're going to do some C++ today.
Yeah, so we're going to do some tips and tricks.
Awesome. Any of this stuff new? Has it been around in the product for a while?
Most of the stuff I'm going to show has been in the product for a while. There's a few things that were new to Visual Studio 2015 Update 1.
Okay.
So nothing incredibly bleeding edge.
All right, cool. And then maybe you'll give us a taste of some things that might be coming in the next version.
Yeah,
maybe.
Talk about a couple things.
All right, cool. Let's see it.
Absolutely. So here, let's go down to my machine. I have a console, C++ console application I've written. And when I kick it off to go ahead and run, I'm expecting it here to tell me, hello, Andrew. So I have a username that I thought I was passing in. So obviously my first bug is that for some reason I'm not actually, something's not going correct.
And there's an option
right there.
to corrupt the heap. I love this game.
This, yeah, this is kind of the kitchen sink of apps. So we have a guessing game, play guess what. We can calculate some prime numbers, we can corrupt our heap, and we can quit, of course.
Cool, all right.
What's an app without the ability to quit?
Exactly.
So first thing I'm going to do is I'm just going to stop debugging. I'm going to come back here to my project properties. And when I come down here, scroll down, so I'm going to right click on the project properties. I'm going to go to the debugging tab. And I can see that in project properties, I have the ability to pass in command line arguments. I can even specify environment variable values. So that can be just a useful thing while debugging. I can see here that I am passing in /user Andrew, and that I have max guess of 30. So I'm passing in my command line arguments as expected. So my sort of the bug where I'm seeing /user isn't that I forgot to pass something in. So it's actually a bug in my particular code. So let's come in here to where my game application starts. And so let's go to our main function. Let's just put a breakpoint in here. Let's go ahead and start debugging again. And so as I come in, I have a diagnostic tools window over here. We're going to talk about it a little later. So I'm just going to unpin it. It'll fly over here to the side. And as I step into this greet user, I can see that I'm sort of generating via WC out. I'm printing this whole line of stuff. So the first tip is as I step over this line, in the autos window, the debugger is going to show me the return values of all the functions that were called on that particular line of code. So in a case like this, where I have a bug, I'm doing multiple function calls on a line, instead of debugging down into each one, as a really quick way of just sort of seeing everything that happened on that line, I step over that line of code, all the function calls right here, you can see get punctuation, return to exclamation point, get username, return /user, get space, or get white space, return a space, and get salutation, return hello. So I can see that my issue here is in the get username function. Right. So I'm going to use another piece of functionality in the debugger that can be really useful, and it's called set next statement. So I can either access that by right-clicking and say set next statement, or I can simply click and drag this little yellow arrow, and that decides what instruction is about to execute next. So I move the execution back up to line 118, which means I'm going to execute line 118 again.
Right.
And this is a really useful piece of functionality for doing things like this, like you missed it and you want to go back so I don't have to restart the application again.
Yep.
You can also use it to force the debugger or the program to execute down different conditional blocks. So you want to debug into what happens. You have an if statement. It's actually going to be false because of the state of the application, but you're still curious. You just grab that little yellow pointer, move it inside the if block, and your program is now executing inside the if block, even though that would have evaluated to false.
Right.
So now I want to get down into get username. I could click on it, I could go to definition, I could set a breakpoint, or I can right click on the line of code, I can say step into specific, and this is going to show me all the functions that are going to be called in this particular line of code, and when I choose get username, I can see that I'm going to step down into that get username function. In this particular case, I can see that I'm simply returning the username.
Is that step into specific a C++ unique feature, or is that in all the languages? Step into
specific is unique to C++ and C# and Visual Basic.
Okay.
So for the sort of the big three languages, we have step into specific.
Okay.
It doesn't work for things like JavaScript, Python, some of the other languages that we support in Visual Studio.
Okay.
But you do get it for sort of those three core languages in Visual Studio. So I can see here that get username, it's already too late. It's just returning a property. So I need to actually, it appears that my bug here is while I'm actually parsing this. So I'm going to get back up to my main function. And the way that I'm going to do that is, this is a fun piece of functionality, is you can right click, and if I say run to cursor, it's going to actually run the debugger back up to where that particular frame on the call stack. So I'm going to right click, I'm going to say run to cursor on here, Control F10 will do it, and then boom, I'm back up here. So I'm going to go ahead and use my set next statement functionality to go back up here to where I'm creating these user options, which is where I'm actually doing the parsing. And just because I can, I'm going to go F12, and I showed you run to cursor in that particular place up. User options, but I need to do that. I went to the wrong place. So let me go ahead and unpin some of these things for now, just to make our editor a little bigger. And so down here where I'm parsing this particular user options, I'm going to go down here to where I'm looking if it's the user arg. I'm going to right click in my editor, and I'm going to say run to cursor here as well. So I used it in the call stack window a second ago. It's going to run to this line of code now under the debugger. So it's basically a one-time breakpoint. You don't have to do it through right click. Control F10 will actually run to that location as well. So you just click and hit Control F10. Okay. So we can keyboard shortcuts for anything that we have in the context menu as well. So I can see here that as I go down, I'm going to go ahead and step through this code to try to see what's going on. So I can see that it goes inside the if block correctly. I can see that it's assigning username and it's parsing this out of the args. But I can see that what I really intended to do here was I should have done the x++ above accessing that particular array index. So if you look down at all my other parameters, it's x++ to increment that, then I retrieve the number for my array. So in this particular case, looks like I just screwed that up. I put the x++ after, so I'm actually retrieving the argument itself as opposed to the value of the argument. So I'm going to use edit and continue, which is something we've had in the debugger for a while, but new to Visual Studio 2015, you can see I'm debugging the 64-bit version of this application, and we've never had edit and continue for 64-bit C++ debugging.
Right.
The other thing about that's new to Visual Studio 2015 is when I'm doing edit and continue, I'm actually using the default debug engine. And so that means I get functionality that we've added since Visual Studio 2010 to native debugging. So in Visual Studio 2013, edit and continue was an option under tools options, but it actually fell back to the Visual Studio 2010 C++ debug engine, which meant I didn't get things like NatViz, which I'll talk about in a few minutes, or the async call stack work, or some of the other cool stuff that we've added since Visual Studio 2010, because that was a long time ago.
Yeah, okay.
So I'm going to grab the instruction pointer, I'm going to drag it back up. You can see that the debugger is going to recompile that, and then when I hit F10, I'm going to step over that. It's going to execute my compiled code, and I can see that username is now correctly set to Andrew.
Cool.
So without edit and continue, or with edit and continue, no need to stop debugging.
Right.
Just able to make changes on the fly. Works for x86, works for x64, and that's by default out of the box in Visual Studio 2015.
Very nice.
So that's one of the things we're really proud of. Worked really hard on that. So let me go ahead and hit F5 here, and my console application should pop up, and now I can see that it says hello Andrew here, the hello user from the times where I did the set next statement, so we re-executed that code, which is why I printed it 3 times.
Right.
So next thing I want to do, how do you feel about playing a little guessing game, Robert?
Yeah, let's do that.
All right, so let's hit 1 and say, play guess what. And the first thing I can see is I'm getting this invalid stoy argument here. So I have some issue popping up. It doesn't look like it was fatal to the application.
Guess what a stoy is?
No, because you shouldn't be seeing that.
Okay.
We're not expecting you to see that. So we have a little bug
that
going on
would have been
in
my
our application.
guess, by the way.
Yeah, well, yeah, it's not a real number. So what I'm going to do is if I go look in the output window.
What is a stoy, by the way, for us people that aren't C++?
It's a function that converts text to an integer.
Okay.
So you'll see that in a second. So I'm going to go back here to the debug pane. So I was on the build pane by default because I had done an edit and continue, so it showed me the build output. But I can see that I'm having an exception thrown. So I'm going to go to the exception settings window, which the capability is not new in Visual Studio 2015, but the window itself is new. It's really fast now. And that's available under Debug, Windows, and we have exception settings. And you can see that it comes up really fast now. So before it was a modal dialog that was pretty slow.
Yeah.
We got a lot of frustration about that. And we have a really good modern search now, as opposed to before, again, it was a very dated search. I think the dialog dated back to like Visual Studio .NET or something from like 2000.
Wow.
So let's just say std exception. So that's the C++ exceptions. Let's go ahead and clear that. So I'm able to do one. I'm able to just turn on all the exceptions for a category as well. So I can search for a specific one. I can just turn them on for a category, and I can go. And so now what's going to happen is the debugger is, let's go ahead and exit out of this. And let's go ahead and try playing guessing again. It should now break whenever that exception's thrown. Because obviously it was being handled correctly. We see that we had invalid story argument, but the program didn't crash. It just let us keep playing. I'm going to go ahead and hit 1, and I can see that the debugger broke, and it's telling me that there's an invalid argument exception. And so when I go ahead and click break, I'm going to walk back up my call stack because I had something called show external code. This allows me to collapse or hide code. But anyway, so I'm going to go ahead and walk back up here, one line to my code, and I can see that what's happening is I'm trying to parse this nums value, which is actually nothing. And so if I look back up, somehow I added some really complicated logic using getLine, and I'm doing some custom parsing, and all I really needed to do was to do a cin to my integer. So in this particular case, I could just say, let's go ahead and comment this out, use edit and continue again, say std cin nums. That should have done it. So let's go ahead and hit F5. It should apply that change. Boom, pop back up. Let's exit out of this. And when I go play, guess what? Perfect, we fixed that exception.
Okay.
So the issue was, it was actually the way I was doing the get line. It was getting the new line character when I hit enter to enter my previous selection, and then it was trying to convert the new line character into an integer. So when you were seeing the stoi, the function that converts text to an integer in C++ is stoi, and it wasn't happy trying to convert a new line to an integer because it's not actually an integer.
Okay. So you were able to tell it to blow up so that you could see what line of code it was actually blowing up on.
Exactly.
Handling the exception is great for a user, but it doesn't help you figure out what was causing the problem.
Exactly. So instead of stepping through my code and like waiting till I see the exception occur, I just go into exception settings, I change that setting, the debugger actually stops where the exception's being thrown, and then I can figure out how to fix it right then and there. So it helps me find that really quickly.
Yep. Cool.
All right, so let's enter a guess and say number between 1 and 30.
Oh, 1 and 30. 25.
Too high.
Too high. 20. 15.
Should have started with 15, right?
10. 5.
You got
Hey!
it. So it took you 5 guesses in 13 seconds.
There's a mathematical technique for doing that, but I decided just to decrement by 5s.
Fair enough.
Which is probably inefficient, but that's okay.
That's all right. We didn't do it in a binary search fashion, but great. So with that, next thing I want to do is I'm going to go ahead and do calculate primes. So we're going to kind of shift modes a little bit. We've got the application up and running. Ultimately, we're going to convert this into a client-server application. I'm going to have a server that's going to actually run, and then when I kick off the client, like the guessing will happen on the server. So that way I can run that in Azure someday, and I can go put this on all the devices in the world, and I can make my millions with my guess what game.
Awesome.
But as part of this, we're going to security is based on calculate primes, so we're going to calculate primes for some good reason. And when I do this, as I kind of go down this list, I can see that it spit out all the primes between 1 and 100.
Including some that aren't primes.
Including some that aren't primes, exactly. Which one do you see that isn't prime?
Well, I see the 9, but then I see a 25. I know those two aren't. I'm sure there's others.
Yeah, there's a 49 down here that isn't prime either. So you're absolutely right. Like we have some particular bug here where we're printing some numbers that aren't prime. So 9 we concluded was one that wasn't prime. So let's go ahead and dive in and see if we can figure out what's going on in this particular piece of code. So I'm going to go over here to my primes, and this.
You can make that the guess game. Guess which of these are not actually primes.
Fair enough. I like that idea. So what I'm going to do is I'm actually calculating these primes in a multi-threaded fashion. So instead of calculating them linearly, because calculating primes can be slow, I'm going to take advantage of all the cores on my particular machine. So first thing I'm going to do is I'm going to set a conditional breakpoint. This is prime function, and I only want to stop when my particular number is 9 was 1, right? That we were calculating. So I want to say candidate equals 9. So conditional breakpoints are a great way to have the debugger, kind of like we did the exception settings a minute ago, only when to stop for the exception thrown. Conditional breakpoints can say, I'm not going to actually ask the debugger to stop until it's the number that I know is the problem in this particular case. The other types of conditions we have while we're here, we have a hit count, so I can do that based on a hit count, and a filter. Filter lets me choose, when I'm actually doing multi-threaded things, I can choose information like the thread ID or the process ID that I'm debugging. In the case of a conditional expression is conceptually anything I can type inside an if statement that would evaluate to a Boolean. So let's go ahead and accept this, and the way that I got there, just worth pointing out, as I hovered over the breakpoint and I clicked this little thing here, I can also get in here via right-clicking and click conditions. The toolbar that I'm showing up here was new to Visual Studio 2015, but the capability to right-click and go set a conditional breakpoint has been in the product for quite a few releases. All right, so we have that set. Let's come in here. Let's go ahead and choose to calculate primes again, which is number 2. And what I'm going to expect is I'm going to expect that the debugger is going to stop, and candidate is going to be 9.
280,000 milliseconds?
We'll talk about that in a little bit. Let me step real quick.
Was it really that much?
I'll talk about that in a little bit. It's a great question, and I'll answer your question.
That would be like 280 seconds? No? Am I doing my math right?
What did it say?
280,000 milliseconds, or was that 0.28 seconds?
I actually didn't see the number.
All
but
right.
so since you asked about it, what the number here is it's called a PerfTip.
Yeah.
We'll talk about it a little bit. PerfTip shows me the elapsed time since the last time I entered my break state.
Right.
So the whole time that we were talking while the application was running, that number was being counted. So it probably was pretty slow because we were sitting there talking, right? So I can actually go back to the Didactic Tools window.
Okay.
I have a history of it here. And so, yep, 280,048 milliseconds. So that would be 28 seconds.
28 seconds.
Right?
Right.
Yeah.
Okay, okay. All right. So that was counting time that the app was running while we were just talking.
So what the PerfTip does, and again, we'll talk about this in a little bit, but it counts. So you can see that I ran from this breakpoint and I hit F10 to step.
Yep.
So now it tells me less than or equal to 1 millisecond elapsed.
Got
So it
it.
simply tells you how long the application was running between states.
Right.
So that's why actually we can come back in here real quick. So I hit F5.
That's kind of a good tip for people because when we talk about the PerfTips, when we demo them, we say, it doesn't include the time we've spent talking about this, right? Because you step through your code and then you stare at it, and the PerfTip doesn't include that time that you were staring at it during debugging.
It counts the amount of time your application's running.
Right. But if you do start the app and then stare at it and then break, then it did include the time we spent staring at it in that case.
So it measures how long your app's running.
That was why I was surprised.
App's up here running.
Right. Okay.
The debugger doesn't know if it's running because it's sitting there waiting for user input, or if you're actually intending that to be fast and it's not.
Right.
All what we know is, hey, your app's running, so we're going to tell you how long the next time you hit a breakpoint or you stop on your next step that it took from the last time you stopped to this time.
Right.
So now when I come in here and say 2, calculate primes, right, I'm going to hit that again, and it's going to be 60. You're right, 280 was 280 seconds. You're absolutely right before. So we were talking for quite a while while it was sitting in that state. That's right, because we played the guessing game in there too.
Got it. All right, cool.
I calculated some primes.
That's actually a good tip, that if you're going to be using this, make sure that you're not accidentally counting time where the user is looking at the app and where the pause is supposed to be part of the app, right?
Exactly, yeah. So we were apparently talking for a minute there while it was sitting there running, and we were chatting away. Again, so candidate here is 9. So I'm going to take advantage of another feature that I really like when doing iterative stuff like this, and that's the ability to click this little pin icon over here, and it's going to stick it. I can drag it anywhere I want in the editor. So now I know what the value of candidate is. And so as I step, right, I don't have to hover over it every time. Again, sort of the same deal. We measured how long the application ran, and it took less than 1 millisecond to step from there to there. So I mentioned I was calculating this in a multi-threaded way. One of the questions we get asked a lot is, hey, I'm doing multi-threaded debugging. like what's the best way to debug that and understand what's going on in the application. So one of my favorite windows in a case like this where you're doing something in parallel and you want to understand what's going on is to use the parallel stacks window. I'm going to go here, and it's available from the debug windows. One of my favorite tips in Visual Studio, not directly related to debugging, but you tend to open a lot of tool windows while debugging, is the quick launch or Control Q. So instead of accessing things from the debug Windows menu, I can actually just go up here to here. I can hit Control Q or click up in the top right and say quick launch, and I can start typing parallel, and I can open my parallel stacks window. And when the parallel stacks window is going to open, it's going to show me all of the threads at the moment that are running my code. So in this particular case, I can see that there are 13 threads total in the application that are running an external code. And so this is something I briefly mentioned earlier, but we have something called just my code. So if I right click and I say show external code, what we're attempting to do is collapse all the stuff that we know is system or framework code and not yours. It's not part of your application. And so when I say show external code, you can see that this is going to get really ugly really quick. And most of these threads aren't doing anything I particularly care about. Right, so there's one thread and something here, and 11 threads doing this, and this just all addresses. I don't even know what that means at the moment. I haven't loaded symbols for them, which is why it's not even giving me meaningful function names. So I'm going to go ahead and right click. I'm going to turn off show external code, and I'm back to, I'll call it the view of the world, where I understand what's going on. But that's a tip to understand.
That's just your code.
This is just my code.
Right.
Exactly. Stuff that's compiled into my application. Which in this case is only writing the is prime. 5 threads are in the write prime. And then I have one thread that's just taken a slightly different path, but is also in the calc primes function. Okay. So what if I want to know, so it looks like I have actually 7 threads right now that are actually calculating a prime or in the process there of it. So if I want to know what all of those threads are doing, we have a tool window for that. So, in Visual Studio, I like to say we have a window for that. So Control Q again. Control P is not what I wanted. I don't need to print anything. And I'm going to go ahead and type parallel watch. So we have a parallel watch window. And what the parallel watch window is going to do is I'm going to go ahead and stick it down here, under here. It's a nice way to look at it. And when I enter something, it's going to show me the value across all the threads that are currently in the current location. So in this particular case, I've already typed candidate here. I could go ahead and, if I cleared it out, you can see enter, right, so it goes away. I can click to add watch. I can type candidate again, and it's going to show me the value of the candidate variable across all the threads that are currently executing. So the little yellow arrow shows me the thread that I'm currently on. That's 9. That's what we would expect because we set a conditional breakpoint to only stop at 9. But I have these other threads that are calculating if 43 is prime, if 3 is prime, 23, 9. Or 19 and 37. So parallel watch, really great way to see variables, the value of a variable across all of your various threads. Right. So in this particular case, I want to debug what's going on with 9, and I don't necessarily want to deal with the rest of my threads. So what I'm going to do is I'm going to come into this particular thing, and I'm going to go ahead and select all of these threads. So I should be able to right click up here, say select all, and then come back. Select all. All right, well, it's all right. So I'm going to go ahead and do this. I'm going to go ahead and flag all of, not that thread. I'm going to go ahead and flag the thread. And I'm going to right click on this thread, and I'm going to say freeze this particular thread. So what the freezing is going to do is it's going to prevent that thread from actually executing. Okay. And by flagging the other threads, I'm adding them to a group, and you'll see why that's interesting here in a minute. So I'm going to go ahead and say freeze. Boom, and I'm going to go ahead and come in here, and I'm going to freeze this particular thread, or sorry, no, I'm not going to freeze it, I'm going to flag it, sorry. Thaw, so thaw is the opposite of freeze. Makes sense, I'm going to go ahead and just flag that particular thread. So what I want to do now is I want to come down here, and I want to go to this particular line here. I'm going to right click, and I'm going to say, we did run to cursor earlier, I can run all of my flag threads to cursor. And so running all the flag threads to cursor is just going to get them into a known location that I can just let them sit. So this write prime up here, there's actually a writer lock. So it prevents, because of some concurrency issues, you can get weird formatting in the console window when you're printing them. I actually take a lock. and I don't want to stop any threads that are currently holding a lock because my other
Okay.
thread's going to eventually deadlock on that. So I'm going to go ahead and click, I'm going to say run flag threads to cursor. So I'm going to get all of those threads back out. And it looks like some of those were already done, so they're never going to get to that particular location in code, which wasn't good. So we'll go ahead and restart that. So that's the danger of run flag threads to cursor and concurrency demos in general, is you don't actually know what you're going to do. But let me go ahead and go ahead and flag all of these threads again. Boom, 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 boom. And we're going to go ahead and freeze number 9. I'm going to go ahead and come in here. I'm going to go ahead and flag you. And let's go ahead and just run everybody to this particular line of code right here. Run flag threads to cursor. Hopefully enough people. So basically what's happening is some of those threads are never, like they're actually like finishing executing and they're never getting spun up, which is why I'm running into this issue where it's just it's waiting for like all of those threads to actually get to this particular line of code. That's okay. We can live with that. So let's go ahead and just restart my one more time. Concurrency demos never quite work out like you want, and so just because things are always shifting around in the particular program. So all I really need to do is I need to get all of whatever threads are currently holding my lock. I need to actually get them out. So if I want to know which threads are currently actually inside this lock location, I can go up here and I can right-click or not right-click, but click the Show Threads in Source on the toolbar. And so what this is going to do is this is going to show me all the threads in which particular line of code that they're actually on. So what I want to do is I want to get all of these particular threads out of here. So I'm going to go ahead and come down to my thread again. That's right here. So if I unset this breakpoint, you can see this one here. So let's go ahead and freeze this thread like this. Let's go ahead and now we'll make the flag threads to cursor work. If they decide to, oh, really? Got something I found to fix. So now we'll get them out of the lock. We'll say run flag threads to cursor. Perfect. Now they're all outside the lock. Nobody's holding a lock. And so what I'm going to do in this particular case is now I'm going to come in and I'm going to freeze all of these threads. So I'm going to go ahead and right click. I'm going to say freeze, and I'm going to freeze all threads below. So none of those are going to run. And the beauty of this is, remember I was up here on this thread 9. So now when I hover over this, right, I can see in my source that I have all these 7 threads that are here, and I have 1 thread that's here. So I'm going to go ahead and thaw this thread. And then to show that it's going to work like I want, I'm going to go ahead and set a breakpoint here. And when I hit continue, notice that candidate, if I go back up here, has remained 9. And all these other threads are still here. So by freezing those threads, what I'm preventing them from doing is I'm preventing them from running, so it allows me to work with the one thread that I care about in a fashion while not dealing with other threads hitting breakpoints or things like that what I've expected. If it's not possible to freeze because you're going to deadlock or something like that, what you can do is I mentioned it before, but use a filter breakpoint. And what the filter breakpoint does is the filter breakpoint allows me to specify, I could do based on the thread ID. And I have the breakpoint location toolbar specified right now. It's an optional thing to turn on. And by having that on, I can see the thread ID just on the toolbar. I don't have to go look in the threads window or the parallel stacks window or anything else. So I could say thread ID equals 10,004. And then that breakpoint would only hit on that particular thread, regardless of the value of
And the
candidate.
reason you did this is there are 8 threads each running that code, so every one of them would hit the breakpoint, and you'd have no idea. You'd have to keep stepping until you got back into the thread that was the one you wanted to look at. So this way you've frozen the other ones, so you can watch that thread working with candidate 9 go through each line of code.
Exactly. So in case you're wondering, it actually turns out that my bug here, all the numbers that we noticed that were being figured out were primes. That weren't primes were perfect squares. And that's because my bug here is I have less than instead of less than or equal to the square of the object.
Got it.
So that should now go ahead and fix that particular issue. I'm just going to go ahead and stop debugging here. We'll go ahead and restart. We don't need to. And so now when I go ahead and do this, instead of unfreezing all of our threads, let's go ahead and calculate primes. And you shouldn't see any more perfect squares in there.
Cool.
So it looks like we fixed that. The last thing I want to show here is something, and you mentioned that maybe we could do a sneak peek of what's coming, and I'll talk about this, is debugging heap corruption can be a really big pain in native code. So I'm going to go ahead and corrupt my heap. Much like multi-threaded stuff, it's unpredictable what's going to happen. I'm hoping my application's going to get really unhappy here in the near future. And it sometimes takes a few. But eventually, it's going to die because I'm corrupting the heap every time I do this. There you go.
Oh.
Right, and so it crashed in some random location. And notice every time I chose that particular set of options, it actually corrupted the heap. Okay. So I corrupted my heap multiple times, and it wasn't until like the 4th time that I chose some option, which could have been a completely different option unrelated to heap corruption, that it actually crashed. And you can see where I crashed is I'm actually simply calling the standard cout and trying to print a message. And so that really shouldn't be crashing.
Right.
And the problem is at this point where the exception actually occurred, it's not interesting. The bug occurred a long, long time ago where I overwrote memory that I hadn't intended to overwrite. And so what's the best way to debug that? And this is a piece of something that's actually built into Windows. At the moment, I have to use the command line to turn it on, but I'm happy to announce that in Visual Studio 15, so not 2015, but the version that we're shipping previews of right now, we're going to be adding the ability to turn this capability on through the Visual Studio UI. Cool. And so the functionality is called Page Heap. And the way that I do that is I installed the Windows debugging tools. So they come from the Windows SDK, and they bring a utility called gflags. And so when I turn gflags on for my particular application, so it's /p, that's the page heap, /enable, and then guess what _singleapp.exe is my particular application, it's going to have a performance impact on the application. But what it's going to do is it's going to actually stop me raise an exception, just like when I turned on first chance exceptions a little bit ago, when I corrupt that heap.
Okay.
So now let's go ahead and turn this on. It's going to tell me that it's enabled. And assuming I type the name of that correctly, let's go ahead and trigger my local Windows debugger. I'm going to go ahead and say heap corruption. And I'm going to say Robert. And I can see that Visual Studio has broken and has told me that an access violation exception was raised writing the particular location of memory. And so actually if I look what I'm doing here, I'm creating a message, I'm disposing it, and then I'm writing information back into that memory that's since been deleted. And so that's why I'm corrupting my heap. Once I've freed the memory,
that's bad.
It goes back. I don't own that anymore, but I still know the address of it, and I'm writing new data into that address. So I basically said, Robert, I'm returning it to the general resource pool, which means somebody else can get it, but now I'm writing over somebody else's memory potentially.
As a C# guy, I don't have to ever worry about that.
You don't have to worry about that as a C# guy. But this is one of the more painful things to debug. And so the gflags capability, I think, is worth throwing into a tips and tricks talk. And I mentioned we'll expose the way to turn that on through Visual Studio version 15. Through Visual Studio, you won't have to go get gflags and turn it on.
And you turn it on for an application?
Correct. You turn it on for an application. So it does have a relatively, significant 20% or so performance overhead on the execution speed of your application. So you wouldn't want it on for the whole operating system, for example. It is possible to do that, but your Windows is going to run a lot slower. And then when you're done debugging page heap, you want to go ahead and turn that off. So you just want to call disable the same thing, and it's going to go ahead and now disable that for us as well.
Cool.
All right, so we talked a little bit about PerfTips already, so that had been one of the things I wanted to talk about next. But PerfTips can be really useful for narrowing down performance problems as you're stepping through code. Since we're on the subject of memory, I want to go ahead and show our integrated memory tooling into Visual Studio. So I'm going to come over here now, and actually I mentioned we were going to turn this into a client-server application.
Right.
So now I'm in my client-server world. I have to start my server here. So let's go ahead and say I didn't start it before this, so let's go ahead and start that real quick. And cdx64/debug, and guess what, server.exe. All right, so that server is going to be running. And so now when I press F5 over here, in this particular application, should start for me. And now I should be able to enter a guess. Now we're between 1 and 100.
1 and 100, 50.
And I'm actually not thrilled with that. It felt a little sluggish to me while I was doing that. I don't know if you noticed that or not, but let's try 50 again, because now we don't want to get it. I'd expect that to be a lot snappier, because I'm running everything on my local machine. So I'm going to go ahead and come in here where I'm getting the...
I was probably counting on the fingers of each hand. So.
Yeah, so let's go ahead and just... And that's right, it's counting on the string. So let me go ahead and set a breakpoint here. Let's go ahead and do our 50 guess again, just because we don't want to accidentally get it. Boom, and I break on that, and so now when I step, I can see this PerfTips taking 470 milliseconds to do this build query base. Because what I'm doing now, let's go ahead and get rid of our parallel stacks and our parallel watch window, is I'm going to be passing information back and forth between the client and server using this C++ REST SDK, and that's going to be doing JSON. So I'm building this query, and I can go ahead and step through my code. I can see how long it takes. And looks like most of that particular time is actually being spent in building that query base. So as I step here, I'm going to go ahead and let's go back up. Let's go back in here. And so if I want to know what's actually happening in this particular time, if I click on this, the diagnostic tools window opens. And with the diagnostic tools window, I'm going to go ahead and pin it now because we're going to be spending time. I can see that I'm actually pegging the CPU. Considering there's multiple cores on here, it'll show me that tooltip should pop up here. It's like 13% of all processors. It's a 4-core machine, so I'm actually pegging one processor pretty good while I'm doing that. And if I want to know what's going on, we have an integrated CPU profiler that was new to update 1 as well in 2015. And so what this is going to do is I'm going to be able to go in here and expand and look at what my CPU is actually doing. And so as I follow it down, sorry, let's go ahead and drag this up a little bit now. I can follow the hot, we call this the hot path, and I can see where I'm building query base, and then as I scroll down to my query base, I can see that I'm doing a bunch of string functions. So I'm concatenating a bunch of strings that's actually expensive in using my CPU. So without the need to stop debugging and go run a different profiler, I simply use PerfTips and the integrated tools in the debugger to identify a problem in my code. And it actually turns out I don't need to build this query base every time because the query base stays the same, and I simply append the guess every time. So I've already taken the liberty to add a local variable. I think it's that, if I remember correctly. The compiler will yell at me if that's not it, but a local variable that should be the value of that. Oh, this one's a little bit slower to recompile because of the whole C++ REST SDK set of dependencies. We've actually identified a performance issue with that, and we're fixing that. But all right, so there we go. Thank you. And so now when I go F10, you can see that that was really fast. My query is the same. I hit F5, boom, 50. Let's go ahead and unset this breakpoint, and I would expect this to be pretty snappy now. Helps if you remember to unset all your breakpoints. And I think we fixed our snappiness problem.
Cool.
So it feels pretty snappy. While I'm there, I want to briefly go back here and look at my diagnostic tools window. And we'll go ahead and expand this out here. And I can see something that concerns me here. Notice that my memory has been ticking up the whole time that I've been doing this. So much like we have integrated CPU tooling, we have integrated memory tooling as well. I need to turn this on. Again, this is off by default, much like PageHeap, because it introduces a performance hit to your execution speed of your application. So I'm going to go ahead and enable snapshots to begin heap profiling. I'm going to take a snapshot, and this is going to set a baseline for me. And the nice thing about being integrated with the debugger is you can get really fine-grained control. So let's go ahead and come in here, where I'm going to go ahead and say F9. Let's go ahead and set a breakpoint. So I can say 50 again, hit that breakpoint. I can take another snapshot. I can see what's changed. Nothing's changed between those 2 points. So I can do snapshots while the program's running or at a breakpoint. But now I can step over this line of code. I've executed only one line of code. And in this particular, sorry, it helps come back here. I can go back to my diagnostic tools window. I should pin that again. And I can take another snapshot, and I can see that I've allocated 694 additional kilobytes in that time. When I click on this, it's going to open a diff view for me. And let's go ahead and do view full screen. It's another view mode of the editor. And so that I can see what's changed, I've allocated one additional gresult object type. And as I've allocated one additional gresult object type, I can see that it's big, so that's where all that memory is going. And when I come in here and click on this, I can see the instances of that. Because I'm stopped in the debugger, this is the advantage of being at a breakpoint, or when I stop that, I can actually inspect it in the debugger. I can see the values of it, just like I could in the watch window. So if I'm trying to figure out what's this object type, I can help answer that question. And then when I come over here, I should, I don't know why. So let's run just a little bit longer to see maybe things are going okay. So let's go ahead and say F5. Boom. Let's do one. Maybe it was going to get cleaned up a little bit later. That's suspicious, but we'll take one more snapshot. I went down 11 kilobytes, so something's still in there. 0 count diff between those. Okay, so let's keep going. But now I can go back and I can baseline this between snapshot 1 and snapshot 2. So if I go back and baseline between snapshot 1, sure enough, there's still one G result created, so I'm leaking that somewhere. And when I come in here, when I select this, I can go to the source code where I'm actually allocating that. And so I can see that I'm allocating this G result pointer, I'm returning it up here, but actually it turns out that I'm never freeing that object. So this is where I get it back. I come down here, I get that pointer. So if I were to simply add a delete to go ahead and delete that guess result, that would go ahead and fix that particular issue for me. The last two things I want to show while I'm here is mentioned G result. And so let's go ahead and do one more guess. It helps with the right thing. 50, boom, come back to Visual Studio. And so when I look at this particular guess result value, it's not a very pretty view. Right, so I have this guess, which is kind of interesting, but then I have this binary data that I don't care about at all. I have a server result, and all I really care about is the actual result of that server result. So if I want to tell the debugger how to visualize this and present it in a nicer fashion, I can add what's called a NatVis file. That's an XML way to describe my the way that I want the debugger to actually present this. And new to 2015, you could always do a NatVis, but you used to have to go down into the Visual Studio installation directory under Program Files and modify the built-in NatVis file. We added the ability to just simply add it into your project. So you can see I just have my.natviz in the root of my guess what CLI project. And when I uncomment this, Control KU, I'm going to save it, and you're going to see the debugger is going to instantly update it. I don't even have to stop debugging. And now, right, it just tells me guess results too low. And then when I expand it, I can see the guess, and I can see the result. So a guess was 50. It was too low. And if the other group that I was seeing before is hidden under this raw view node. So NatVis are a really useful way to describe stuff that you actually want to, like how you would want to look at your objects, not necessarily how the objects are formatted in memory. The last thing I want to show was also new to Visual Studio 2015 Update 1. So let's make a guess of 101. Let's not hit our breakpoint. And we're going to break on a read access violation. And so the issue here is I have a couple chained pointers. So I'm going to come down here and show this real quick, right? So I have guess result, arrow server result, arrow result. And then it equals this value dot as integer. So something triggered an access violation. How do I know what? We tell you now. So we're telling you guess result, arrow server result was 0 f. So I can see the server result wasn't initialized correctly. So this is one of those little things, but it can save quite a bit of time. Right? So when you look at this line of code that I'm on right here, right, there was 1, 2, 3, 4 potential things that could have triggered an access violation. Instead of hunting or going to the watch window, hovering over things, we just tell you now as part of the exception message that pops up in Visual Studio.
Cool. Cool.
So I think that's what we had time to talk about today, Robert.
Very cool stuff. So again, a lot of this stuff's been in there for a while. Some of the stuff new to 2015 or a couple of the updates.
Correct.
And you gave us a taste of what might be coming down the pike.
That's right.
Cool. So when the pike arrives,
that's right.
When we are down the pike, we'll have you back and you can show us more stuff that's new in the next version, which is right now in preview.
That's right.
Preview 2, I think, right?
Yeah, preview 2's out. There'll be a preview 3 coming up at some point in the future.
All right. Cool. So we're getting there.
That's right.
Getting there.
Just keep watching. Expect to see regular previews.
Thanks for coming on.
My pleasure.
All right. Hope you enjoyed that, and we will see you next time on Visual Studio Toolbox.